Hello friends, I am George Mekwan and welcome back to JJ's Classroom. I hope you like my all videos, then don't forget to hit the like button as well as to subscribe my channel and share with your friends. In today's lecture, I am going to discuss with you the solid liquid extraction. So let's move to the topic. Okay, that is our question. Explain solid liquid extraction by some examples. First of all, the definition of solid liquid extraction. Okay, as I quoted here, the separation of a desired constituent from solid sample can also be achieved by extraction with an organic solvent in which the solubility of any other substance present is too small to be negligible. Okay, so यहाँ पे हम ऐसे कह सकते हैं इसे the well-known example of a solid liquid extraction is rose water. Okay, if you put some rose petals into a water for 10 to 15 days, then you know what happen after 15 days when you remove those petals from the water. Okay, that water now has essence or smell of that rose petals. So what happened there? The essence or from the rose petals are extracted by the water during those 10 to 15 days. Okay, so that is called extraction of essence from solid petals by water, that is in a liquid phase. That is a well-known example of a solid liquid extraction. If you have more examples of solid liquid extraction, then you can suggest me in the comment box also. Okay, so here I can also say that the simple definition of a solid liquid extraction is when you put organic substance or a solid substance in water or in a solvent for long time, long days, then what happens? The constituent from that substance is extracted by the solvent. That process is known as infusion. That is also the word is used, infusion. So there are two types of continuous extraction for solid are used. Okay, here the word is already mentioned: discontinuous infusion type extractor and continuous infusion type extractor. Infusion, that means the separation of or the extraction of solid the extraction of a constituent from a solid substance with the help of a solvent. That is called infusion process. It takes a few days. The first topic, the first diagram here, that is a discontinuous infusion type extractor. That is a diagram. Here some symbols are there. D is a reflux condenser, T is a thimble, N is a tube siphons, M is a tubes, and C is your round bottom flask. Okay, we check one by one them. So in discontinuous infusion type extractor, that assembly or apparatus is known as a Soxhlet apparatus. Okay, well known example of discontinuous infusion type extractor. So T, capital T, is a thimble. Okay, here that is a thimble. Okay, thimble is one type of membrane. Okay, that is made of tough filter paper, which is inserted in the wider inner tube. So that is a wider inner tube in which the thimble is placed. It is one kind of a membrane. Then you know what is a membrane. It allows to pass one material and it block the it like semi-permeable membrane. It allows to pass a liquid or a solvent and it block the solid component. It's like this. Okay, so it's a semi-permeable type membrane. And the capital C is a boat head flask containing the solvent. We can say that it is a round bottom flask used in organic chemistry practical and other practical also. You already know that round bottom flask here. So your solvent, okay, that is put or that is filled in a round bottom flask, boat headed flask. D is the reflux condenser, as I mentioned here, that is your reflux condenser. These two ends are, you know, that is connected with a water source, tap water or any other source. Okay, now your solid component, that means the sample, the solid material from which you want to extract the constituent, are put on a thimble. Okay, then that is connected to the extracted, that is both head flask and a reflux condenser. So this statement is for this whole assembly. This is the extractor with thimble, reflux condenser and a round bottom flask. Our sample is put here, and that is your thimble. Okay, that is the membrane, and your sample is put it here. Then that is the process how salt constituent is extracted from the solid. First of all, the solvent is now allowed to boil gently. Okay, then its vapor are passed through the tube, and you know when you boil your solvent, okay, it vaporizes, and those vapors are then passed through this tube. Get here, the arrows are given here already. That is the tube M. Okay, then it enters in a reflux condenser here, and you know the function of a condenser. Okay, what happens in a condensation? The vapors are converted into solvent, or we can say that liquid. Then this liquid in a form of droplets. Look at here. Okay, these drops are of your solvent. Okay, these droplets are then falling down and fall onto the substance that is kept on a thimble. जो भी हमने थिम्बल पर हमारा जो ऑर्गेनिक सब्सटेंस रखा हुआ है, जो भी ड्रॉपलेट्स है सॉल्वेंट की, वो ड्रॉपलेट्स कंडेंस होकर कहाँ पे गिरेगी? सीधे वो जो मटेरियल हमने रखा है उसके ऊपर आके गिरेगी. वो सेमी परमिएबल मेम्ब्रेन है, तो क्या होगा कि जो भी ड्रॉप्सलेट वहाँ पे उसके ऊपर जो गिरने वाली है वो वहाँ से फिर पास हो जाएगी, और जब वो ड्रॉपलेट्स थिम्बल को पास करके जब आगे बढ़ेगी तो क्या होगा? वो सिर्फ सॉल्वेंट नहीं होगा, लेकिन वो जो सॉल्वेंट है उसने ऑर्गेनिक जो सब्सटेंस है उसमें से जो भी हमारा कंस्टिट्यूएंट है उसे उसने एक्सट्रैक्ट फिर कर लिया होगा. उसे हम कहाँ पे फिर कलेक्ट करेंगे? दैट इज द नेक्स्ट स्टेज ऑफ कलेक्शन. ओके, दोज आर, लुक एट हियर. Then this solvent is collected here, that is called tube siphons. And okay, यहाँ पे these vapors are condensed by dip, and the condensed solvent falls into the thimble containing tube solid. ठीक है, जैसे मैंने अभी आपसे बात की. नेक्स्ट स्टेप मैंने जैसे आपको बताया, when the solvent reach the top of the tube N, that is your tube siphons, tube N, it siphons over into the flask C and removes amount of solid which it had extracted in the thimble T. ठीक है, यहाँ से फिर हम उसे वापस आप निकाल सकते हो. यहाँ से सीधे कहाँ पे आगे गिरेगी? यहाँ पे. ठीक है, अभी इसमें क्या होगा? जो भी सॉल्वेंट यहाँ से ट्यूब सिफॉन्स में से जो भी सॉल्वेंट यहाँ पे ड्रॉपलेट के तौर पे यहाँ पे जो गिरेगी, उसके अंदर क्या होगा? आपका जो भी जो सॉल्यूट है जो आपने एक्सट्रैक्ट किया है सॉल्वेंट की सॉल्वेंट की मदद से, वो वहाँ पे आप कलेक्ट कर पाओगे. फिर इसे डिस्टिलेशन या किसी और सेपरेशन मेथड के यूज करके आप वो जो सॉल्वेंट है उसमें से आप अपना सॉल्यूट सेपरेट आउट कर सकते हो. ठीक है, दैट इज द मेथड ऑफ डिसकंटिन्यूअस इन्फ्यूजन टाइप एक्सट्रैक्टर. If you have any doubt regarding to it, then you can ask your question in the comment box. Now this process is repeated automatically until the extraction is complete. The amount that has been extracted may be isolated from the solution, okay, by any of the usual methods. Now B, that is a continuous infusion type extractor. In this extractor, the substance is placed on a sintered glass plate. Okay, that is also one kind of a membrane. You can also assume like asbestos sheet that is used in a laboratory purpose. Okay, this apparatus is available commercially. Okay, now the use of continuous infusion type are: number one, that used for separation of lithium chloride from sodium and potassium chloride, may be carried out by masking the use of normal butyl alcohol or higher alcohols, because only lithium chloride is soluble in these extracting solvents. Okay, so that is the first use of continuous infusion. the separation of LiCl2 from sodium and potassium with the help of some masking agent like higher alcohols. Second, that is the separation of potassium perchlorate from lithium, sodium and magnesium perchlorate, that also can carried out by taking a mixture of equal amount of alcohol, normal butanol and ethyl acetate. Okay, in this mixture only potassium perchlorate is soluble. That means when you use higher alcohols, in that higher alcohols only lithium chloride is soluble, potassium and sodium chloride are insoluble, you can easily remove them. Okay, similarly in normal butanol and ethyl acetate mixture, potassium perchlorate is soluble while lithium, sodium and magnesium are insoluble, you can easily remove them. Then a well-known separation of calcium, strontium and barium can be affected by first converting them into anhydrous nitrate, then extracting with a soluble alcohol. So these are the three use here of a continuous infusion type extractor. Now the later solvent on only calcium nitrate is soluble. That means in calcium, strontium and barium, when they are converted into nitrate, only calcium nitrate is soluble. So it reduced is then converted into chlorides by repeated evaporation with HCl. When you react with HCl, what happens? Those nitrates are converted into chlorides. That is SnCl2 may then be extracted with absolute alcohol with BaCl2 remains behind. Okay, now these are some diagrams of, I can say figure of the sintered glass plate. Okay, that is commercially available, that is a sintered glass plate. Okay, and the arrangement of this sintered glass plate on a conical flask is like this. Okay, that is a setup in practical. So dear friends, that is all about today's lecture. I hope you like the lecture. If you have any doubt regarding to these two topics, then feel free to ask the question in the comment box, and don't forget to like my channel as well as to subscribe it and also share with your friends. Thank you so much and thank you for watching.